Hello, and we're going to deal with section 1-2, which talks about graphing equations, either with circles or any type of graph that we have. We also are going to talk about symmetry in this section, but with this I'm going to show you a couple different ways on how to sketch a graph given an equation. So first thing that we're going to have is if they give you something like this. The first way that we're going to do this is by what I call plotting points. And what that means is that we're going to put, for our problem, the first step that you're going to do is you're going to pick random numbers to put in for y, or put in for x. Then step 2 is solve for y. Thus what you're creating is you're creating ordered pairs. And then once you do this, step 3 is you're going to plot ordered pairs and connect the dots. Okay? Connect dots. So on this, a lot of times what they say, it depends on if you know what the type of shape it is. 3 points is enough for this particular thing that I put on there, but not enough for some of the other curves that we're going to do later on. So you'd probably want to go at least 5 points, maybe even more, just to see. But once you'll notice, and once we get further into the course, we'll actually see that this is actually a line that we're going to graph. So again, the equation is 2x minus y equals 3. And I'm just going to make a little table, and I'm going to put in here numbers. Now I usually pick, if I know it's a line, or if I don't know it's a line, I'm going to do 5. And if that's the case, I'm going to do 2 negatives, 2 positives, and 0. Which numbers you put in there, it's totally up to you. I usually like to stick around 0 if at all possible. So those are my 5 numbers that I'm going to insert. So negative 2 is going to go in for x. So I've got 2 times negative 2 minus y equals 3. 2 times negative 2 is negative 4 minus y equals 3. Add 4 to both sides. Negative y equals 7. Divide by negative 1. And I end up with y equals negative 7. And I'm going to continue through the process here now as I'm talking through the problem. And I'm going to do the same thing. The only thing I'm going to do differently is I'm going to insert a new number for that in that x spot, and hopefully get equations or shape that I want to see. So now again, with this one, you'll notice maybe, or maybe you did already, if you didn't know, or if you knew anything about this stuff, that this was the shape of a line. But if you didn't know, you could continue doing this as many times as you need in order to actually get the shape of what you're expected to see. So let me just do the last 2 here. 2 times 1 is 2. When I subtract it over, I get 1. Divide by negative 1, I get negative 1. 2 times 2 is 4. When I subtract that over, that gives me negative 1. Divide by negative 1, and I get 1. So I'm going to take these things right there, that set of data, and I'm going to plot it on a coordinate plane, and then I'm going to connect the dots. That's what I'm going to do. Now unfortunately I need a new slide for this. But my x and y, we had negative 2 with negative 7, negative 1 with negative 5, 0 with negative 3, 1 with negative 1, oops, that looks like a 7, and 2 with, I believe, positive 1. Okay, so what I'm going to do now is I'm just going to connect those, or draw those dots in there. Again, I labeled my axes like I did on section 1. But 1, 2, and then 1, 2, 3, 4, 5, 6, 7. Make a dot. Then again, over 1, 1, 2, 3, 4, 5, down 5. 1, 2, 3, down 3 because I have 0, so therefore I was good that way. And I have a nice nice looking shape like that. So again, this is the plotting points method. All I'm doing is inserting numbers in for x, random numbers. It does not matter what numbers you pull it in. You can do any number that you want, but what you do then is once you insert these numbers over here, the numbers you get out, they pair with them and make ordered pairs. Connect or put them on a coordinate plane, and then connect the dots after that. I'll give you one more. Right, this one's a little bit different. This is not a line now, so now I'm going to do 5 for sure. So if I put -2 in there, that gives me -2 squared. Ugh, that's ugly looking. I'll change that. -2. Well, -2 squared when it's in parentheses like that gives me +4, and 4 minus 2 is 2. Now I'm going to put -1 in there. -1 squared is 1. 1 minus 2 is -1. If I put 0 in there, 0 squared is 0. Minus 2 is -2. I'm going to put 1 in there. 1 squared is 1. Minus 2 is also -1. So now I'm starting to see maybe a little bit of a pattern. But when I do the 2 in there, I also get 2. So it's not a line, but something's happening there. So hopefully we'll see what the shape is, or the outcome here with this. So if I go -2 and up 2, make a dot. -1 and down 1, make a dot. Down 2, make a dot. Over 1, make a dot. Okay. Now, this type of shape, and I knew what kind of shape it was, but this type of shape, ugh, ugly looking again. But this is a parabola. A lot of people try to make these look like a V, but it's really more of a U shape. It's a nice smooth curve. I knew it was a parabola because that number right up there was squared. When just the x is squared or just the y is squared, it is a parabola. Okay, so that's one way of graphing, again, is just by plotting points like that. That will work for all of them. I am going to recommend, though, that when we get into some of the bigger ones that have more variables, you're not going to want to do it that way because there's going to be curves all over the place. And if you wanted to do the plotting points method, you're going to need a lot of points, and that's a lot of extra work for you. So just be careful with that. That's the one downfall with that one that I'm going to show you. That it does take up some time. It takes a little bit of extra work too. On a different note, the other thing that we can do is use our graphing calculator. Now I actually don't have my graphing calculator with me right now, but I'm going to walk you through what you have to do. So the first thing that you need to do is solve your equation for y equals. Now the reason why we do that is because in the graphing calculator, especially the Texas Instruments calculators that we use, is that in order to insert graphs into that, it needs to be in y equals format. Up in the upper left hand corner there's a button that says y equals, and then that's where we type it in at. The last one that we had, that y equals x squared minus 2, we are actually already set up and ready to go. And it's already got the y equals, so bypassing step number 1 is okay. Step 2 is we're going to put it into calculator. And by it, I mean equation. Into calculator. And how I do that is I will hit y equals. And first of all, you got to hit on, but y equals. And then you're going to hit a button. There's a couple different ways that you can get x. One of the ways that you can get it is, if I remember right, I believe it's above the store button, but realistically right above or right next to the alpha button, there's a button that says xt, theta symbol, and n. That's the fastest way of doing it. Okay, there's a button that says x, t, theta, and n. If you do that, that will give you x. And then you hit the x squared button. And on your screen you should have x squared, and then you just type a -2. And when you do that, everything should be set up. Now, as far as seeing the graph, then the next thing that you would push is you would just push the graph button on the very far right. If it does not show, then what happened is that your window is a little messed up. In order to adjust the window, there's a couple different ways. One of them is you hit the window button and you insert the different things for that. Or you can, to get it back to a standard window, one of the things that you can do is go down to zoom, and it's number 6. Zoom 6 refers to the standard factory settings. It's a 10 by 10 by 10 by 10 window. That means 10 in all directions. 10 to the right, 10 to the left, 10 up, 10 down. Okay? So just to kind of give you those, X minimum is the same as left. X maximum is the same as the right. Y minimum is down. And Y max is up. So, just so in case you're wondering, as far as getting that all set up for you so that you can see it, if you typed it in like I have over here in this little spot, and if it didn't show, if you go zoom 6, or if you go to the window and actually type what you want to see, it'll actually show it to you exactly like how we graphed it by hand. So just so you know, that's what the graphing calculator does. Now, I'll try to have a couple graphing calculator ones up here in a little bit, but that's using your graphing calculator. On the first equation that I gave you, if it was set up as 2x minus y equals 3, then what you want to do is you want to solve for y first. So you'd have to subtract 2x to both sides, getting minus 2x plus 3, and then dividing everything by negative 1. And in this case, I'm going to do each piece by negative 1. So 2x minus 3. Then I can put this into the graphing calculator. The graphing calculator will not accept it when it's in that original format like that. So if they ever ask you to graph absolute value equations would be like this. The fastest way and easiest way to get it in absolute value is if you hit second and the 0 button. That second and the 0 button will take you into the catalog. And if I remember right, it's the very first one. It stands for, it's ABS is what it has. ABS is short for absolute value. That way on the newer types of 84 calculators, it will actually give you the absolute value symbols. On the older ones, it will say ABS parenthesis, and on the newer ones, it will give you this with like a little shadow box that you can type everything into that you need. So just so that you know, that's how I'm going to use the graphing calculator. And I'll show you here once I get, actually mine's out of batteries right now, so I'll get some batteries and get it working so I can show you guys later. But and a third way that we can graph is using what we call the intercepts. Intercepts are nothing more than where does it intercept or intersect the x and y axis. Now, not all of them are going to have it. That's the downfall to it. But the way that you do it is you plug x equals 0, solve for y. And then you plug y equals 0 and solve for x. That's how you find the intercepts. The downfall, or I shouldn't say downfall, but the one thing about this is that some of them might not have any intercepts, it might only have a y-intercept and not an x-intercept, or vice versa, or it might have multiple ones depending on what kind of shape it is. For instance, that parabola that we graphed, it would have had 2 x-intercepts and only 1 y-intercept. So you got to be careful with that. But as far as finding the intercepts go, that is exactly what we would do. Is we would put 0 in for x, solve for y, put y equals 0, solve for x. So on this equation, y equals x squared minus 2, the one that we graphed, if I put 0 in for y, I have x squared minus 2. Now, if I want to solve for x, I would have to add 2 to both sides first. And then how do I get rid of squares? Square root. And when you square root, something that's important that most people forget is that you should have a plus or minus the square root of 2. That's saying that if I have the square root of 2 and square it, I should get 2, and also negative the square root of 2 and square it, I should also get 2. So it's important to have plus or minus there because a lot of people do miss that you would only be solving for one side of the parabola, not two. So be very careful with that. And then if I do the other one, y equals 0 squared minus 2. 0 squared is 0. 0 minus 2 is y equals negative 2. So what I could use that for when graphing is if I set up my set of axes here, 1, 2, that means it crosses here. Now square root of 2, it's a 1 point blah 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 blah. So when you do that one, you want to go make it out to 2 and then go about halfway or not quite a halfway. I think it's like 1.4, goes on forever. So anyway, that graph and the one that we graphed before are very similar. That one's actually a little bit smoother than the first one. But that's how you would use the intercepts to graph. And some of the questions just say find the intercepts. If it just says find the intercepts, then that's all I have to do is put 0 in for x, solve for y, 0 in for y, solve for x. And just as a recap to how I'm solving these is I'm undoing the order of operations. The order of operations states grouping symbols first, then exponents, then multiply, divide, then add and subtract. Well, I'm working the opposite. So I get rid of adding and subtracting first, then I get rid of multiplying and dividing, then I get rid of any exponents, and then I get rid of the grouping symbol last. So I'm working in reverse order of the order of operations. That's how you solve an equation. So with that being said, those are the ways that we're going to graph equations, at least for this first day. Once we get into knowing a little bit more about the equations and whatnot, we'll use some transformations later on in chapter 2. But those are how the 3 techniques that we're going to use to graphing. The next thing that we have to deal with is we have to deal with what a circle is. Now the circle equation that you're going to be most familiar with or be using is x minus h squared plus y minus k squared equals r squared. H and k is the center. And so the center of the circle, right smack dab in the middle, that's going to be the coordinates of h and k, and r by itself is your radius. And radius, again, for a circle is how far is it from the middle out to the edge. Okay, so that's the equation that we're going to use. If the circle is at 0, 0, so if it's at the origin, if you remember that from the first day, or from the first section, that's x squared plus y squared equals r squared. The one thing I want you to notice is for a circle, both these two pieces right there are squared, and that's adding. All right, so those are the things that you're going to see. If you see x squared and y squared with an adding symbol in between it, that is going to be a circle. Okay? So first thing that they're going to have you do is they're going to have you graph a circle. Now, I'll be honest with you, my first time graphing circles, especially using my iPad here, they tend to not look like circles. But with a little practice, it does come out. So first of all, what I'm going to look at is there anything in parentheses with the h? Is there anything in parentheses with the y? There was not. So if there's not, then my center is at 0, 0. So that's the first thing that I need to figure out is, what's the center? Where's the center at? So my center is at 0, 0. Then the radius is going to be this number over here square rooted. So the square root of 25 is 5. Now I do not put plus or minus this for this one because a radius is actually a distance. So therefore it should never be negative. So that's why when we say a radius of 5, we do mean 5 in all directions. But for that particular concept, we're not going to put plus or minus like we would if we were solving an equation. And what I'm doing now over on the side is I'm trying to carefully draw 5 in every direction. Now here's where the hard part comes in. Where the 0, 0 is in the center, now what I'm going to do is with my hash marks here, I'm going to try to connect them as best I can. 5 all the way around. Okay? So it's a lot trickier than it looks like. That's not even the best one that I've done, but it's pretty close. But as long as you're close to it, I would think that as long as you have, something similar to it, as long as you have things labeled as far as the center and the radius go, you should be fine. And that's going to go a long way if you have your center and your radius labeled. Then, if I give you one that does not have a center at 0, 0, plus y minus 1 squared equals 25. Okay, again, what I want to do is I want to identify what number's in the H position and what number's in the K position. Now, it's really tricky with this one because when it looks like it right now, it looks like minus 2 is in the H position, but that's not true. The original formula said x minus h inside the parentheses and y minus k in parentheses. What I usually tell students is that when you pull out a number from a parentheses like that, basically what happens is that the sign changes. So my h is really 2, and my k is really negative 1. So what that means is that instead of starting at 0, 0, I'm being shifted over. And you'll hear me use those words later on, but I'm being shifted over 2 and down 1, and that's my new center. I still take this guy up here and I square root it to get the radius, which again is still 5. Now I'm going to go 5 in every direction from the dot, not from the origin. So I've already gone over 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oop, that one's kind of a little short, but as long as we're close to it. Got it. And down here, I kind of make those a little bit longer there, and the reason for that is to try to force myself to stay out wider with the circle, just because it's so hard to make just an oval or an egg-looking shape, and I was doing pretty good until the end one. But that's how you would graph one with a different center other than 0, 0. Okay? And then the next thing that they're going to have you do is they want you to come up with the equation. After they have you graph it, if I say the radius is 3 and the center is negative 5, I want you to just insert those numbers in and write the equation down. So it's x minus 2 goes in the H position squared plus y minus negative 5 goes in here. But two negatives will turn that into a positive. And then if now I have to take the radius and square it, which 3 squared is 9. And that's all I want you to do. Okay, it's not overly complicated for that. They don't want you to be, there's not going to be too much math involved with that one. The only thing that would be a little bit more work for you on that is if it were to say something like find the equation of a circle that has the points as the endpoints of a diameter. Now a diameter is the distance across that, so you would need two things. You'd first need the distance, which we learned in section 1, and you'd also need the midpoint, because that's where the center would be. And again, that's all section 1 stuff. And the last thing that we're going to talk about is symmetry. Symmetry is a type of thing that will cut it in half where it matches on both sides. And what you're going to do is you're going to test for symmetry. You can use it to help you graph, but realistically you're going to test for symmetry. There's 3 different types of symmetry that you're going to test for. The first is x-axis symmetry. And how you do that is you replace y with negative y and simplify. And once you do that, it goes into 2 different things. If oh my god, did I spell right? Oh, I can spell it right. Simplified. If simplified, and it's equal to original, then yes, it has it. If simplified does not equal, then no. Okay, and that type of type of thing is going to be exactly the same for all three of the different types, but with x-axis you're replacing the y with negative y and simplifying it, and then you have to do the same thing with the x and everything else. So the next type of symmetry that's going to be out there is going to be y-axis symmetry. And when you have y-axis symmetry, you replace x with negative x and simplify. Original, then it's yes. Not original, and it's no. Okay, I tried to just simplify it or make it a little bit easier, you know, put it in a little bit different terms, but it's the same kind of concept. And the last type that we have is with respect to the origin. When it's a respect to the origin, that flips it over the line y equals x, but for this one you replace both x with negative x and y with negative y. Original, then yes. Not original, and it's no. Okay, so the equations that I'm going to have you do, it's going to say test the equation for symmetry. You're going to plug the number. You're going to plug it in and see what happens if it has symmetry or not. So on something like that, I've got y equals x to the fourth plus x squared. So the first one I'm going to do is negative x is going in. Y equals negative x to the fourth plus negative x squared. When it's in parentheses like that, four of them, negative x times negative x times negative x times negative x is positive x to the fourth. Negative x times negative x is positive x squared. That's the original, so therefore, yes, it does. Now I'm going to do negative y. Negative y is going in. I divide by negative 1. Y equals negative x to the fourth minus x to the squared. That would be a big no, because it is not the same as the original. Now I'm going to do origin, which negative y and negative x is going in. Now something that I ran out of room there. Either way, it's not going to have it, because I have negative y equals x to the fourth plus x squared. I'm going to divide everything by negative 1, and I get the same as the last one. So that's the respect to origin. This is the respect to x-axis. And this would be y-axis. So out of the three, we would actually have y-axis symmetry for that problem. There are some things out there that would have more than one axis of symmetry, which would mean that if I were to graph that, I could cut it right down the middle vertically. I can go up and down with it, and I can cut it in half, and it's the same on both sides. If I was a x-axis one, I could cut it horizontally, and it would be the same on both sides, and origin would be a diagonal. There are some shapes like the circle that would have all three, but some of them don't have any. So as far as section 2 goes, that's all that I would ask you to do. There's a couple other things as far as circles go, but we need to learn how to complete the square first. So in the directions, when you look at it, it says determine whether the points are on the graph. They're going to just ask you to plug those in. 15 through 40 says graph the equations. It says make a table of values, but however you want to graph it, that's totally up to you. 41 to 46 says use the graphing calculator to graph the equation in the given viewing rectangle, which means we just change the rectangle. That's that window thing where I gave you the x minimum and x maximum and stuff. And then we adjust it from there. X and Y intercepts, it says to find it for the next little bit. And then I ask you to do a couple circles and some symmetry. So anyway, that's section 2. See ya.